So this is the second lesson, rational numbers. So first go through rational numbers. First you studied. So what is natural numbers, what is whole numbers, and what is integers. First you studied that one. So then after you study rational numbers. So first natural numbers. So what is natural numbers? So it is denoted by capital letter N. So natural numbers denoted by capital letter N. So what is the natural numbers? So it comes naturally. So you know that. So how you usually count the numbers? So you count like this: 1, 2, 3, 4. So you not starts with 0. So usually count starts with 1, 2, 3, 4, 5 like this. So natural numbers are counting numbers. Natural numbers are counting numbers. Therefore 1, 2, 3, 4, 5, so on. So there is a 1, 2, 3, 4, 5, so on. So natural numbers are counting numbers. So 1, 2, 3, 4 are called it as natural or counting numbers. Okay, next, whole numbers. Whole numbers means 0 together with the natural numbers are called whole numbers. 0 together with natural numbers are called whole numbers, and whole numbers are denoted by capital letter W. So the set of W contains 0. One extra term you have 0, and the remaining all the terms you have, see that it is a natural numbers. So 0, 1, 2, 3, 4, so on. So this set you call it as whole numbers. So including 0 you call it as whole numbers. So now you understood natural numbers and whole numbers. So next, integers. So there is one more addition. There is one more type of addition for the set whole numbers. You see that integers. So from here to here you see that this is a set of whole numbers. So 0, 1, 2, 3, 4, so on. So the same set W. The addition is -1, -2, -3, -4. So what do you call it as? Negative integers, or so is a negative natural numbers, and you call it as negative integers. So this one you call it as positive integers from 1, 2, 3, 4. So these are all positive terms. From this one you call it as -1, -2, -3, -4, so on. You call it as the negative numbers. Okay, this is the set of integers, and simply you write it as 0, plus or minus 1. You see that one is +1, one is -1, plus or minus 2. So +2, -2, +3, -3. So plus or minus 3, plus or minus 4, so on. The set of integers contains 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. So I explain one more time using number line. So you see that, so this is a number line. So it starts with 1. So here 1, 2, 3, 4, 5. You see that? So this is you call it as natural number line. So if you include 0, then it is a whole numbers. So you see that. So here increases 1, one more 1 means 2, 3, 4, 5 increases. So here, so now you show the number line of integers. Show the number line of integers. You get 0 here, middle, and 1, 2, 3, 4. Okay. So as going this side, the value increases. As going this side, the value increases. You see that 0, 1, 2, 3, 4. 4 is larger value. And you see that here, now it is -1 is here. After 0, -1, -2, -3, -4. This is a number line of integers. 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4 is a set of integers. So now you go through rational numbers. Now you go through rational numbers denoted by the letter Q. So So now is the rational numbers denoted with the letter Q. A rational number is a number that can be written in the form P by Q. So you can written in the form of P by Q, where P and Q are integers and Q not equal to 0. So this is very important. Anyway, the denominator cannot be 0. Denominator is cannot be 0. So a rational number is a number that can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. The simply you write Q equal to the set P by Q, where P and Q are integers and Q not equal to 0. So I given some examples. 1 by 9 is a fraction. So is in the form of P by Q. You see that. So in the P place you have 1, in the Q place you have 9. Both P and Q belongs to integers. You see that the set of integers containing 1 is there and 9 is also there. 4, 5, 6, 7, 8. After you get 9. So 7 you see that. So it is not in the form of P by Q. So you see that is not in the form of P by Q, but I write in the example of rational number. Why? Since 7 can is also written as 7 by 1. So 7 by 1 is in the form of now P by Q. Correct? So that means, so every integers, every whole numbers, every natural number that can be written in the form of rational numbers. So I take an example. 2. 2 is a natural numbers. So in the rational form I write 2 by 1. Okay, I take now 0. 0 is a whole number. 0 is a whole number. 0 can written as 0 by 1. So is in the form of P by Q now. You see that. And I take now integers 1. So minus 4. So minus 4 is also can written as minus 4 by 1. So all natural numbers, whole numbers and integers are belongs to rational numbers now. Okay. So I repeat one more time. The rational number is in the form of P by Q, where P and Q are integers and Q not equal to 0. So I written 7 by 1. So root 16. So value of root 16, you know that is 4. The value of root 16 is 4. Since 16 can written as 4 into 4. Therefore, if you remove this one, you get only 1 4. So therefore, 4 is an integer. So you can written as 4 by 1 is in the form of P by Q. So what is the meaning of 0.5? Is it in the form of P by Q? So this is in the decimal system. So you convert it to fraction means what you get? So 0.5 means, is it half? 1 by 2. If you convert 0.5 to fraction form, you get 1 by 2. So now is in the form of P by Q. So P by Q is a rational number now. So 0.333. So this is in the decimal form. You convert to fraction, you get in the form of P by Q. Therefore, so now we understood what is integer, what is whole number, what is a whole number, what is a natural number, and finally you studied about rational numbers. In the last slide, you studied about the nature of rational numbers. So now you do that addition of natural numbers. Addition of natural numbers. There are two types of addition. So in the rational numbers, in that first one, when the given numbers have the same denominator. The first problem, 5 by 7 and minus 11 by 7. So in the fraction, you get both positives. So in the fractions, you get both the positives. So in fractions, you consider only positive terms. But in rational numbers, you get negative also, because it is include integers. So rational number is you get negative number also. So first one, 5 by 7 and minus 11 by 7. So add. So write 5 by 7 plus, because it is addition. So bracket, since you have a negative sign here. So put one bracket for this one, minus 11 by 7. Minus 11 by 7. So 5 by 7. So you know that sign, multiplication of sign. What do you call it as? Multiplication of sign. Plus into minus. Minus, plus into minus, minus 11 by 7. So I show that first, how is the multiplication of sign. So plus into plus, Plus into plus, you get always plus. So plus into minus, you get minus. So minus into plus, you get minus. So minus into plus, you get minus. So minus into minus, you get plus. See that? Plus into plus, plus, plus into minus, minus, minus into plus, minus. So both negative means plus. So same sign. If you multiply same sign, you get plus always. So you get, if you multiply different sign, you get negative always. So you think as it is. Okay, now, so you get plus into minus. The first one you get negative. So now, so this is the sign. The first number you have a plus. So if you know sign means you consider it as it is plus. So you see that 5 by 7 not have any sign. So you consider it as plus sign. It has a plus sign. No sign means plus sign. So plus 5 by 7 and minus 11 by 7. So in integers you studied that. So if you have 1 plus 1 minus, you subtract. So 1 plus 1 minus, you subtract means, so this is the larger one. So 11 is the larger one, 5 is the smaller one. So 11 minus 5, what do you get? 6. So 11 minus 5, you get 6. And the larger value sign, so 11 is the larger one and the sign for the 11 is negative. So put here. So minus 6 by denominator as it is. So minus 6 by 7. So minus 6 by 7. Similarly, second one, 7 by minus 9 and 8 by 9. So you put addition now, here plus now. So minus 7 by 9 as it is, plus 8 by 9. So now 1 is minus, 1 is plus now. So 1 is minus, 1 is plus, you subtract now. So the denominator is same. So 1 is plus, 1 is minus, subtract means 8 minus 7 you get 1. 8 minus 7 you get 1 and the larger value. So 8 is the larger value. The sign for 8 is, so that is plus. So plus means you don't write. So if it is nothing is there means sign. So you take it as plus. So next problem, 7 by minus 9 and 8 by 9. 7 by minus 9 and 8 by 9. So you see that, so minus is in denominator. Minus is in denominator. So you know that denominator you get same. So what do you do that? So you do that, multiply minus 1, both numerator and denominator. So you have to multiply minus 1, both numerator and denominator. What do you get? So 7 into minus 1, you get minus 7. So minus into minus, you know that is plus. So it become now plus and 9 into 1 you get 9. So plus 8 by 9. So now you have a common denominator. So that is 9. So both are different sign. One is minus 7, one is plus 8. So subtract. So two different sign. So subtract 8 minus 7 you get 1. And the larger value sign is plus, therefore answer is 1 by 9. So second type, when the given numbers have the different denominator, when the given number have the different denominator, I take one. So you see that the denominator, one is 4, one is 9, here one is 16, one is 12. So first one, minus 3 by 4 and 2 by 9, minus 3 by 4 and 2 by 9. So first, so you see that different denominator, you can't add. So you first you have to find the common denominator using LCM. So we have to find common denominator using LCM. So take two denominator 4 and 9. So now you divide using 2, first prime number 2. 2 2s are 4, 2, 9 as it is. Therefore one more time 2 1s are 2. So 9 as it is. So next you go through 3. 3 3s are 9 and 1 as it is, and 3 1s are 3. Therefore 2 2s are 4, 4 3s are 12, 12 3s are 36. So now the common denominator or LCM is equal to 36. So write here. So you write here it is 36. So now the common denominator, that means for this minus 3 by 4 and 2 by 9, you have the common denominator is 36. So now adjust numerator, that means we have to adjust the numerator such as it is equivalent to minus 3 by 4. So we have to adjust the numerator. How you adjust? So you know that 4 how much the 36? 4 how much the 36? 4 nines are 4 nines are 36. You write very small using pencils, you write here. So 4 nines are 36. Therefore minus 3 into 9. So you multiply 9 into 9 into 9, both numerator and denominator. So minus 3 nines are minus 27. So 9 how much are 36? 9 fours are 36. So multiply 4 here also. So 2 fours are 8. So minus 27 plus 8 divided by 36. So minus 27 plus 8. So both different signs. So one is minus, one is plus. Subtract, you get 27 minus 8 means you get 19, and the larger value sign. So 27 is the larger, so its sign is minus 19 by 36. So denominator as it is. So second problem. So minus 7 by 16 plus 5 by 12. So minus 7 by 16 and plus 5 by 12. So you see that 16 and 12 two different denominators. So first you find common denominator using LCM. So 16, 12, 2 8s are 16, 2 6s are 12, and next 2 4s are 8, 2 3s are 6. So now you go look for only 4, 2 2s are 4, 3 as it is, 2 1s are 2, 3 as it is. Now you go through 3, 3 1s are 3. So 1 comma 1. So finally you get 1 comma 1. So LCM is equal to 2 into 2 into 2 into 2 4 times into 3. So I write here. So 2 2s are 4, 2 2s are 4, 2 2s are 4 into 3. So 4 4s are 16, 16 into 3 you get 48. So the LCM or the common difference you get, so common denominator you get 48. So this is the common denominator 48. You write here, first you write common denominator 48. So now 16 3s are 48. So minus 7 into 3 you get minus 21. So 12 4s are 48. 12 4s are 48, you know that. So 5 4s are 20. So minus 21 plus 20. Minus 21 plus 20 you get minus 1, since the larger value sign is negative. So in that problems the sign is very very important. You can't put plus minus as your wish. So the larger value sign minus is very important. So minus 1 by 48. So here you get minus 19, since you get the larger value here. So minus 19 by 36. So now you know that addition of rational numbers. So now you see the properties of addition of rational numbers. So in that first one, closure property. In that first one, closure property. That means the sum of two rational numbers always a rational number. We have to prove, is it true or false? So the sum of two rational numbers is always a rational numbers. You take two rational numbers. So one is 1 by 2 and one more is 3 by 4. So one is 1 over 2 minus 3 by 4. So what is the common denominator? So 4 is the common denominator. If you do the LCM, you get 4 as a common denominator. So now adjust numerator to get as a common denominator 4. So 2 2s are 4 and you 1 2s are, you get 2, and 4 1s are and 3 1s are 3. So 2 minus 3. So one is plus, one is minus. You know the integer addition. So plus 2 minus 3, subtraction you get 3 minus 2 you get 1, and the larger value sign you have minus. The larger value you have 3 and the sign for that one is minus. So the answer you have minus 1 by 4. So you see that minus 1 by 4 itself is a rational number. Therefore, the sum of two rational numbers is always a rational number. Therefore, rational numbers are closed under addition. Therefore, the rational numbers are closed under addition. So you take more examples. Okay. So next, second one, commutative property. The second one you have the commutative property. So that means two rational number can be added in any order. So the any rational numbers can be added in any order. I take it two numbers. So one is a by b. So first I show symbolically. So a by b means one rational number, c by d. So in that case, so you write c by d first, then a by b. So now I take example. So a by b I taken minus 3 by 4 and c by d I taken 1 by 2. So now change, interchange. So you can change the order. So 1 by 2 plus minus 3 by 4. The first term you have minus 3 by 4. So now you prove that both the sides are equal or not. So minus 3 by 4 plus 1 by 2 is equal to 1 by 2 plus minus 3 by 4. So now you see that order is changed. So what is the common denominator for 4 and 2? So take LCM, you get the common denominator as 4 and adjust numerator with respect to the denominator 4. So 4, so 4 ones are 4, so 3 ones are, so minus 3 into 1 you get minus 3, and 2 twos are 4, so 2 twos are 4, so 1 twos are 2. So similarly in that side, the 4 is a common denominator and 2 twos are 4 and you get 2, so that is 2. So 4 into 1 into 1, so minus 3 into 1 you get minus 3. So plus into minus, minus, you see that sign multiplication, plus into minus, minus. So now minus 3 plus 2 by 4, so both are different sign, subtract, the larger value sign you have negative, so minus 1 by 4, the denominator as it is. So similarly, both are different sign, subtract, the larger value sign for minus is for 3 it is minus, so minus 1 by 4. You see that minus 1 by 4 equal to minus 1 by 4. Therefore, LHS equal to RHS. That means the left hand side is equal to the left hand side is equal to right hand side. That means two rational number can be added in any order. So that is tells in commutative property. The commute meaning itself is A, B, B, A. That means A plus B equal to B plus A. So that is the meaning of commutative or commute, the commutative property, associative law. So that means three or more rational number grouped in any order, the sum is the same. You see that the first one A by B, C by D, E by F. A by B, C by D, E by F. So three fractions you have, or three rational numbers. You have three rational numbers. So A by B plus C by D I grouped here. These two numbers I grouped here. The outside you have E by F, and here A by B plus C by D plus E by F I grouped here. So grouped in, so I grouped first two terms here. So in that I grouped the last two terms, but the first one only, second one, third one itself. So so now I go through example. So A by B I take minus 3 by 4, C by D 1 by 2, and E by F also I take 1 by 2. You take other, so you take 1 by 4 also here. So minus 3 by 4 plus 1 by 2 plus 1 by 2. So now add. So first you solve the bracket according to the rules of the rules. So you have to solve the brackets first. So 4 is the common denominator. Using LCM, 4 and 2, the common denominator, using LCM you get 4. So now you adjust numerator. So 4 ones are 4 and minus 3 into 1 you get minus 3. 2 twos are 4, 2 twos are 4, and into 2 you get 2. So plus 1 by 2 as it is. If you want you put the bracket. So plus 1 by 2. See here. So minus 3 by 4 plus 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2. You have the common difference or same difference. You have the same denominator. You have the same denominator, that is 2. So therefore 1 plus 1, 2 by 2, 2 get cancelled. That means 1. Okay. So you write 2 only here. So minus 3 by 4 plus 2 by 2. So now, so minus 3 plus 2 different sign, you get minus 1 by 4. So minus 1, larger value sign minus 1 by 4 plus 1 by 2. See here equal to minus 3 by 4. So now you find the common denominator using LCM. So that is 4. So into 2 into 2. So minus 3 as it is, because 4 into 1 you get 4. So minus 3 into 1 minus 3. 2 2s are 4. So now minus 3 plus 4. What is the answer? 1. Larger value sign plus, so 1 by 4. Denominator as it is. See here, the common denominator you get 4 using LCM, and you now into 2 into 2. So 2 into 1 or 1 into 2 you get 2. So minus 1 plus 2 you get divided by 4. So minus 1 plus 2. Minus 1 plus 2. Two different signs, subtract, larger value sign plus. So 1 by 4 equal to 1 by 4. Thus that shows that LHS equal to RHS. So that shows that, so 2 or more rational numbers you grouped in any order, so that is equal. That is always equal. So you can make any groups in that. So that is always equal. So that is shows in associative law. Okay, the next one, existence of additive identity. Existence of additive identity. The sum of any rational numbers and 0 is the rational number itself. The sum of any rational number and 0 is the rational number itself. So I go through an example. 1 by 4 plus 0 equal to 0 plus 1 by 4 is 1 by 4. You know that any number add with 0, the number itself. So that is itself shows that additive identity. So 1 by 4 plus 0 you get 0 plus 1 by 4. It is always that number 1 by 4. Similarly, I show it in negative number. So that is minus 1 by 2 plus 0, and 0 plus minus 1 by 2 you get half. That is means 1 by 2. So plus into minus, so you get minus half. So minus 1 by 2, sorry. So minus 1 by 2 plus 0 you get the number itself. Therefore 0 is called additive identity. 0 is called additive identity. Remember, it is very important. 0 is called additive identity. Since any number added to 0 you get the number itself. Therefore 0 you call it as additive identity. Therefore the existence of additive identity, that is 0. So next, existence of additive inverse. Existence of additive inverse. So for every rational number, so you take it as in general A by B. So you take 1 by 2, 1 by 4, 3 by 4 or 5 by 4. There exists one more number such that minus A by B. So you get 1 by 2 means here you get minus 1 by 2. You get 5 by 2 means you get minus 5 by 2 here. So that is such that 1 A by B plus minus this one A by B or A over B plus minus A over B equal to, so minus A over B plus A by B equal to always 0, correct. So A by B, so plus into minus, minus, so A by B minus A by B is 0, and minus A by B plus A by B, that is also 0. So you know that. So now I take an example, 2 by 5 plus, so exist one more number minus 2 by 5. So there is minus 2 by 5 and exist you get 2 by 5. See that 2 by 5, so plus into minus, what you get? Minus. 2 by 5 minus 2 by 5, you get 0. That means 1 minus 1, you write 0. 2 minus 2, you get 0. Similarly, 2 by 5 minus 2 by 5, what? 0. So minus 2 by 5 plus 2 by 5, so that is also a 0. So you know that minus 2 plus 2 is 0, or minus 1 plus 1, 0. So that means, so for 2 by 5, so minus 2 by 5 is the additive inverse. The additive inverse of 2 by 5 is, the additive inverse of 2 by 5 is minus 2 by 5. The additive inverse for minus 2 by 5, that is 2 by 5. Okay, additive inverse of half, that is minus half. So additive inverse of half is, so half means 1 by 2. The additive inverse of 1 by 2 you get minus 1 by 2. The additive inverse of 1 by 4 you get minus 1 by 4. The additive inverse of 2 So 2 itself is a rational number. 2 can written as 2 by 1. The additive inverse of 2 is minus 2. The additive inverse of minus 2 is 2. So that means 2 minus 2 you get 0.